For you to have clicked on this video, that means you want to learn a detailed design of a raft foundation and the concept and the principle entails in raft foundation design. And I'll be walking you through the structural modeling, how to model the slab, and also design for the slab, where you can see the reinforcement for the columns and also for the beams. But after the modeling, we are going to proceed to the structural analysis, which you're going to see where we have to mesh the raft foundation, where you can see the model, and also move to the contours where we have to check for the soil pressure between the weight of the building and the maximum soil pressure that the soil can carry. And we will have to look out for the soil pressure here, following all the effects that is needed here for us to design for our raft foundation. And you can see the soil pressure, so I will show you how to calculate for the soil pressure based on the bearing capacity, and also to look out for the weight of the building, because for any foundation, the weight of your structure must not surpass the maximum pressure that the soil can carry, which I will show you all that in this video. Then we will then proceed to the slab design, where you have to get using the report and then get your raft slab like your rebars, which you can see here on each of them. Then we'll then proceed to our foundation beam design, where you can see that all your beams are all designed for, and we will also check for each of the beams. We will have to check each of the beams like this, and I will also show you some kind of warnings that you can ignore when checking your beams, because you don't just depend on the software, you also check the softwares. Okay, that is fine. Either you add the reinforcement or you decrease the reinforcement. I will show you on that. And also there are some warnings that you can also ignore when checking your beam. For example, warnings like this and other warnings. I'll also tell you why you have to ignore and why you don't also ignore it. And we will also go and look out for the general overview of the building, to look out for if it is perfectly okay. As you can see here, that everything on the foundation is green, knowing that from the contour here, green means okay, and you must make sure that everything is green. But not only green on the foundation, but I will also show you how to perform your engineering judgment, because you don't have to depend on what the software is giving you, but you have to depend on your final engineering judgment. That is why every software or this software has what they call visual interrogation, which you are seeing here on your screen here. And also I'll also teach you how to go to your layout and then look out for the area that has the maximum reinforcement, where you have to come to this place, visual interrogation here, and then come to your FE analysis tab here, come to your FE contour here, and then from your FE contour here you can then come to first. Let's start with our soil pressure, which is the maximum envelope. We come here and then click on OK. You can also see how to you can see the areas that has where the weight of the building is more. As you can see the contours and the pressure from the building, not from the soil. Then also you can also see, if you also navigate to see the place that has the maximum vertical top rebars, which you can see here too. Come here and then load the maximum top rebar here for X direction 1 top or X direction 2 top. And then you can also see the place that requires the area of steel, which you can see this area of steel here, which I also show you all these too on how to design perfectly for a raft foundation. So in this video, sit tight and let's begin for that in the next 50 minutes. Now we are running Ekidel mentorship training, which we are given 49.9% discount, which will end this month of July. If you want to enroll for that, you can check on the link below and enroll that, or go to Google and search for Ekidel mentorship training, which runs for 8 weeks, and it's a detailed practical based training, which we are using Google Meet one-on-one training and not a group training. See you on the training. So for this building, let's begin the structural modeling of the beam raft foundation for this 2-story building. Again, the purpose of using a raft foundation for this building is because the soil is a reclaimed land. So and the city where this building will be built is in Port Harcourt. So the government gave an order that any building that must be built in GRA Port Harcourt, Nigeria, must be built with a raft foundation to control settlement, knowing that it's a reclaimed land, it's a sandfield area. Okay, that is fine. So to do that now, you can see that we have already completed the structural analysis and design of the superstructure. We then follow for the structural modeling for the base for the sub grade, which is the sub base. So in that course now, we are going to use a beam raft foundation for this particular structure, and in that course we will have to do what model our ground beams here. So I'll go to my foundation modeling, then click on beams, and then you will see foundation beams will appear here. I'll click on foundation beams because that's what I want to use for my beam raft. And then I will then set up my beam raft properties. I will be using 225, all right, by the depth of the beam. Since the bearing capacity it's okay, it's just to control settlement, so I will be using a beam raft depth of 800 millimeter in that course. I will assume this. If it fails, we then go higher. Then we then come now and then begin to do what model our beam on the foundation story 0. Click on this now, and then click on this. So you model the beam based on what you have. Okay, that is fine. So the column is actually 150 by 450, but I'll be using the beam of 225 by 800. Okay, that is fine. So then we then come again now, escape now, and then click on this place here, and then move on to here, and then continue again to this other side here. Click here, and again click here, here. Okay, this is the joint of the column. It should be that place. Escape and confirm. Yes, it's that place, because you can see that it has two points that you might get confused of where they are. Then again here. Okay, that is fine. So you just to model the whole interface like this. Okay, so you have to model all the parts of the like to connect the whole columns together using the beam, which I'm doing here currently. So once you have set your beam size, you then continue with that. Okay, so the bearing capacity for this building is 425 kilonewton per meter square. That's what we are using, and that is what the the soil says, like soil report says. So we then model that now and then continue. So I'm going to pause this video and then finish up this structural modeling for this particular beam connection by connecting all the columns together. Then once I'm done with that, I will then come back for us to begin the next phase, which is adding the slabs. Okay, that is fine. I'll then come again here and then insert from here to here. Okay, that is fine. So I'll be pausing this video now and then continue later, shortly come back to you guys. So all you do in your own is to make sure that all the columns are connected with the raft beam. Okay, make sure that they are all connected in the raft beam if you're doing your own. Okay, that is fine. So now, as you can see, I am done inserting all my beam rafts, which you can see by connecting all the columns together and also making sure that my panels are not too big. All right, they are within the 30 meter square area, else you'll be experiencing some kind of deflection on the slab. So if you now go to my 3D model here, you can see that we have now modeled for all our foundation beams. Okay, that is fine. So back to our now what is left now is not to impute our or insert our slab, which is a raft slab. Now there are two type of beam raft foundation. You can either do a cellular raft, or you can do a conventional raft, which is likely an inverted raft, where the slab is meant to be at the top of the beam and not the normal way that the slab is meant to be below the beam. When the slab is below the beam, it is the slab that is carrying the load, but when the slab is above the beam, it is the beam that is carrying the load. So it is actually an inverted raft that is more common in this region of Africa. Okay, that is fine. So we are going to do the other part, which is the one that the slab will be at the top, which is called inverted raft. So coming here now, then come back to our modeling again, click on slab here, and then click on, make sure you are then putting your slab depth. Your slab depth should be 200 for a mat foundation, or for a raft foundation, 200. Now I will then come now, once you put 200, don't put anything here on your loading. Leave your loading to be none. Don't put any value there, because it is just to transfer the weight of the superstructure down to the slab, so you don't have to do anything there. Then come here now and then insert. Once you put your this, insert here the slab here. Now once you insert the slab, go to our 3D model here, you will see the slab appearing here. But now you can see that this slab is below. All right, it is below. So but we want this slab to be above here. So we come back here, click on this slab, edit it, come here, properties of the slab, and then come here and type the level. Our beam depth is what is 800 minus the slab depth of 200. That gives us what 600. So I'll come and put 600 here, and I'll do what, click on what updates. Okay, you will see our slab will appear update. Now then come in and then do what, put our cover. Since it's foundation, we put 50 for cover. Okay, that is fine. So put the cover as 50, which you can see there, and then click on what escape. So in that sense, now you can now see that we now have our slab appearing at the top and no longer at the bottom. Correct, this is fine. So this is what we want to achieve for our raft foundation for the beams. Then we come now and then use the same property of the beam now, of the slab now, and then insert on all other places where we have our slab to be inserted, which we have here and have here and have here, here. Okay, that is fine. So we just continue doing that right now. Now know that our Ekidel mentorship training discount is ending this July, so which is in the next few days, and we are given a 50% discount, which will end this July. So if you want to enjoy that, you can enroll that now, which you can find the link below this video description. If you want to know everything about what you gain by the end of the training, go to Google and search for Ekidel mentorship training or Ekidel mentorship certificate, which you will get all full details about what you achieve and what you will learn by the end of your training. Okay, that is fine. It runs for 8 weeks. Okay, that is fine. So we then click here and then insert all our slabs now, and then continue from here and then put here. There's no slab here, so make sure you put that. Then now escape now, and make sure you zoom to make sure that there's no double slab added anywhere. For like a double slab, you see the text to be double, but in this case, no double slab. So if we now go back to our 3D model here, you can now see that we have now modeled our slab, but there is no a beam raft foundation without controlling for what overboarding pressure that is going to happen below the beams. So in that case, we are going to also add a slab that's going to control for what overboarding pressure within the beams. Okay, that is fine. Most people don't add this, but this is the right way to design, construct a beam raft foundation. But most people choose to ignore it. So in that case, now I'm going to model for overboarding pressure within the slab. So I will be offsetting each of these now. I will offset for I'll offset the slab distance using, I'll be using 500 first to see, then I'll F2 key and then type 500 and then enter. Okay, that is fine. I will make this thing now to be a ghost axis because I don't really need it for anything except for the slab. So I'll come here, ghost axis, that is fine. And again, I'll come again here, offset the same thing, 300 outward like this. Come here and do minus 300 because I am going left. Now I'll check now to make sure, sorry, 500 not 300, so delete that and offset 500 not 300. Come again here and then right click here and then offset here, sorry, another one, offset here minus 500 and then enter. So again, convert this to what, to ghost axis like this. Come here, hidden axis, and then do here and then update. So I will do the same thing now by offsetting everywhere and then come back for the training with you guys again. So currently now I am done offsetting all my edges of my raft slab tool, which is a tool of the slab for the raft foundation, which are these, which I'm just picking now. So once in your own case too, once you're done offsetting like this, then we can then begin to do what, insert our slab. So make sure that you know the point where you offsetted. So in this case, this is my own point. You can see that all have been moved by what, 100. Can you see that? So in this case now, this is not really up to here, so I can choose to stretch it down. So just to avoid any confusion, you can stretch yours down to the point where you know that you don't get confused. Okay, that's fine. But every edges are being moved by what, 100 by 500 millimeter. So we then come now and then insert the toe slab, which takes care of what, for the overboarding pressure. You come here and then come here and then click on this again. It is the same depth, 200 depth of slab, and then this slab now is to be below, not above. Again, it to be below, again having the same thing of 50 concrete cover. Don't put any value on this load here. Now then come now on this place now, I'll be using the cantilever method to insert this because this is actually cantilever. Then put 12, then come here and then insert the cantilever length to be what, 500. Then don't put any cantilever load, just on this alone is okay, nothing here too. And then put your depth and then your cover of concrete, and then come here now and then insert it column to column by clicking like this now, and then clicking here and then give the direction out and then click. So this is meant to be 500, so let's see that 500. Okay, so if it is 500 from this thing, that means that this thing will have to move out by this value. So I'll say no, I don't do that. So basically we have to offset a new one by first of all taking measurement. We didn't cater for the beam thickness, so we come like this now. This is 6125, so that's what we are meant to offset. Okay, yeah, because you always add the beam thickness, like the beam half of the beam width, to your cantilever offset. Okay, so in this case I'll just continue again and then do like this, continue like this again, and then click here and keep here. That is fine. So we are to offset that because this is 500 cantilever length, correct? So we need to offset that grid lines to be 500 plus your beam half width. Okay, that is fine. So again, so offset this by what? By offsetting column to column. Okay, for the toe slab, and continue with that. And again, from here to here. And again, make sure you don't have that elevation added to it, correct? It will be 0. Then, because if you now look at what you've done so far, you can see what you've done so far right now. This is what we have done. You can see it here. Correct. This is those slab I was talking about. Which takes care of what? Overboarding pressure within the beam and ends. Okay, button. Again, come again and then continue again like this, and then you can actually insert this without the inside this slab without the grid lines. Yes, because if you're doing without if you're doing with the grid lines, then you can use a normal slab, which is type 6. But in this, I want to use this cantilever method, which is also nice. Then insert from here to here. So you insert from here to here, because this is where this small beam is, to here, and it is going to flow. It will just flow now. Okay, that is fine. Then you insert from this column to the next column here, which is from here to here, and then insert. That is fine. Okay, it will join. You can see that it has flowed. Then you continue again from, so insert all other places that you have. Insert from here to here, and then click outside, and again insert from here to here, and then you click outside, and again insert from here to here, and you click outside, and again insert from here to the next place, you click outside, and again you insert from here to here, you click outside. It will merge, correct? And again you insert from here to this other side here, and then click outside. It will merge. Can you see that? And again from here to here, and then click outside. It will merge. And again from here to here, and then click outside. It will flush. And again from, let me go now from here to here, and then click outside. It will merge, correct? And then almost the last point, from here to here, and then click outside. It will merge. And again from here to here, and click outside. It will merge again. And again from here to here, and then click here. It will merge. Then this final one now will now merge this to this, and then click, sorry for that, come again from here to, make sure you're at the right point, to here, then click outside. It's meant to merge, correct? It will merge. Now once you have done this, now look at your 3D model here. You can see that we have now defined for our flats, for our slab raft. Can you see the toe slab? So while the toe is below to control for what? Overboarding pressure. The beam is there to carry the load, and the slab is here to transfer the load within these portions, okay, panel bay or panels to the beams. Okay, that's fine. So all of them work together as a whole system. That's why they are called a raft slab. So once you're done with this now, the next thing now to do is to now move on to the to now cut your strip. You must cut your strip, which is the one that you're going to use to the design for your slab. You cut your strip like this, click on your modeling, then click on strip. To cut your strip, click on strip here, and then make sure you choose FE analysis, because that's what you use for raft foundation or for slab raft foundation or for mat foundation. Click on FE strip. Okay, that is fine. Then for the FE strip now, you make sure you are on foundation slab, which is here. Then you come here. This slab is on a different level and here is on a different level, so don't cut the strip together. Start from here, click on this point here, and then go all the way down like this. We are going on X direction. This is X direction, and then cut all the X direction like this, and then click here. That is fine. You click that, and then you cut for the X again. I want to now this that one now. This is a slab, so I'll change at end to slab, and I'll cut. Except I want to cut like this. Okay, C end beam B end. Click here and then cut like this, because there are beams at the ends of the both ends. So beam. Okay, that is fine. Then I want to cut from here to the next panel here on X direction. That is fine. And again, I want to cut from there is two slab here. Can you see? You can see that here is dark. So I will escape now and zoom in. Can you see that it has two tests? So this is the most common thing that you can experience when you're modeling flat slab or mat foundation, is to not to avoid not to have a two slab there. Then come back again now and make sure you are on FE strip. Correct, that's fine. Again, cut again from here. Hold your control key to keep the line straight, and then click here. That is fine. And again, escape, and then continue again from I want to cut from here all the way down here. All the way down here. That is fine. So once you're done cutting for the X, you then cut for the Y. Let's cut the last one here now, from here all the way down here. Now I have one that I have not cut, which is this panel here, and this panel will stop here. So I'll change to slab here at the end. Start from beam, which is already selected here, and end at slab. So end at slab here. Correct. So with this now, we then move to the vertical direction. So change to Y direction now, beam to beam end again, and again I want to cut for vertical now, which is beginning from here all the way down to here. Okay, to here. Correct. And again I want to cut again from here all the way down to here. Correct, that is fine. And again I want to cut again from here all the way down to here. Correct. So with this now, we have cut all our strip. It is this strip we are going to use to design for the slab, to know what is the like the slab rebar diameter or and the slab spacing, okay, for the rebars. So with this now, we are done with our slab modeling completely, and then we then move to this slab structural analysis, which is the raft foundation analysis, which we are going to do the next phase now. Now, once you're done with your modeling like this, to move to the next phase, which is now the analysis, you have to make some settings. You have to come here now and then perform some settings here, setting center, and then hold on for that to display. Now, once this comes up now, we then come here that says foundation here, foundation option here, then click on this this place here. On that general, you see your bearing capacity here. You type in the value. I've already put in my own value as 130, but normally at the default this is always 200, so you change it to what your soil bearing capacity is saying based on your soil report. In this case is 130. I'll put there 130. I'll type my lean concrete, which is like a cover. I'll type 50, and then extension 50 if there is any. Now once I've done that, now we then do what, come back here, design. And then for this design here, nothing much to do here, because you don't have, you're not dealing with this. But what will govern for this is the bidding analysis. So I'll leave it at that, and I'll come now and then click on what OK. So on that OK now, I'll make sure I have saved. Now once I've saved now, before you go and run your structural analysis for your raft foundation, make sure that your superstructure is still active. So I'll come here and make sure it is active. How do I mean active? That this good is ensuring here means that your this thing is still what, your that your superstructure is still what analyzed. So in that course now, we then move on to the foundation for this. And how do you do that now? You come to FE analysis, and before you can do this, you must be on your 𝔼𝕚𝕚𝕚 must be active. So I'll come to 𝔼𝕚𝕚 here and make sure it is active. I normally like doing this from my plan view. Okay, from my plan view on that 𝔼𝕚𝕚. Then on this now, I'll then come here and then click on analysis tab here, and then click on what FE analysis, which is finite element foundation analysis here. And then we then move on to this other phase. Now on this place now, I'll check since I modeled my I have different panels for my slab and not just one full slab. I'll come here and say use subgrade for other slabs. Okay, that's fine. And I'll also I will not check this because I didn't use walls and beams on. Okay, I will not check this one. We then come now and then I will check this column interaction point, although this is basically for when you're designing for a normal matte foundation without beams, so I won't check this. Then I'll check my sparse solver to control any error. Okay, then I'll make sure that my distance is showing 130, which is already locked here. Come back here now and then click on what, and click on mesh here. Okay, then it is now performing what the structural analysis. Hold on for it to finish up. Okay, that's fine. So now you can now see what we have here. You can choose to maximize, and this is showing you all the forces from the superstructure on each of the columns. Can you see that? Into the foundation now. Can you see that? So this is showing you all the forces that we have got so far, which you can see here. So we will then move on to the next phase, which is just to say okay here, and then wait for it to finish up. When it's done, here is going to tick good. Okay, that's fine. Now you can see that it is saying that foundation beam is what completed, so it has not transferred all the load from the superstructure down into the beams. Okay, now come and do what, say okay here. So with this now, we then proceed to the next phase, which is now this particular one here that say, because we have to go down to what two things we are going to do: design for the slab and design for the beams, because we have two members on the foundation for the raft, a beam and a slab. So we are going to first of all design for the slab first. So we come here and then come and perform click on this place here. Now this will open up the soil interaction for your slab. Okay, that is fine. So on that note now, we are now on this place. Now once you come here now, the first thing to do is to make sure you are on the plan view. To go out from this solid model, I'll annually come here and go to this place first that says general. Okay, that is fine. Now on that general now, I'll come and make sure I'm on plan view here, so that it will be on plan view, which I want to see like this. Then we then come now and make sure we turn on our contours by coming here and then say contours. Okay, that is fine. So we turn on our contours now, and then we can choose to close this particular area, this section here. Now once we've done that now, we then have this will show you your deflections of the slab. If the slab is deflecting, but you can see the maximum deflection here is 0.005 millimeter. That's around 5 millimeter, and which is already less than L over 500 and L over 250, which is the deflection based on permanent and finishes. Okay, that's fine. So in this case now, we then move to the make sure you load your moment like this. Now begin to click on moment here. Click this, click this, click this. So and click on all these things here. So make sure you load all this like this. Click on this and click on this and click on this. Now we are going to focus more on this place, which is the wooden armor reinforcement. So I load this one and load this particular one here, and then move to this. Okay, that's fine. So once we come to this wooden armor now, you can see your reinforcement area here is given to you, is showing to you the place that is having but you just can pick the highest one here. Now we have the highest one basically based on the colors. We have purple somewhere, which is most times very tiny. You can see them inside the column. This is red inside here. So the most common type of color that we have here is blue, which can pass with even the slab can pass with diameter 2F at 200. That can pass with this area of steel. If you have your steel chart, check that up. Okay, that's fine. Then we then move to this here. Okay, that is fine. Move to the other ASD button direction. It can still pass with diameter 16, although most of the column points needs a greater area of steel, which we already have a beam running there, so that's not an issue. Okay, that's fine. So this will be a concern if you're designing for normal mat foundation without a beam. Then you have to focus on the column points to add what a punching reinforcement and also what additional reinforcement. But in this case, we are not dealing with a mat foundation. We then come now and click on what here that says for top. Top is always higher because of a mat foundation. So we can see that. Then come to here again. Okay, that's fine. Then we're going to check for the soil. Our main mission now is to check for the soil, the soil pressure between the bearing capacity of the soil and the weight of the building on the soil. So knowing that our bearing capacity is what 130 kg per watt meter square. Okay, that is fine. And then we are using the code for our design, so we are going to apply what factor of safety from our design code. In this case, we are using a code for what, and we are using what Euro code, okay, for our design. So Euro code 7 and 8, no, Euro code 7 for our design says 1.25 for factor of safety for foundation times our bearing capacity of what 130. That gives us what 162.5 bearing capacity. So this is the maximum that the soil can carry, 162.5, and this is the pressure due to the load of the building, which has the maximum of what 73.7. So since this value 73.7, which is the load from the building, maximum pressure from the load of the building, is less than 162.5, which comes from our soil bearing capacity times the factor of safety. Since this value here is less than what the building is coming, so since this value here is less than what the soil can carry, then it is okay. So on no account will this value be more than what your soil can carry, else it is failing. So in this case now, we have verified that our soil pressure between the net soil pressure, what the soil can carry, and the building load is okay. So with this course now, we can then move to our beam design. So in that course, we can then move to the beam design. Now, also most times too, you can also check for the maximum envelope, okay, because most times it is always set at G, which is basically what we use for foundation design, okay, ultimate. But you can also check, sorry, we use G for foundation design, but you can also check for always check for maximum envelope here, which is the worst condition of all the loading condition. So I'll check for this again here, and you can see that let's see if the value is less than 162.5. Yes, you can see that here is 107, which our value is also the weight of the building is less than 162.5, which is what the soil can like carry maximum. Okay, that's fine. So once we have verified for this and everything is okay, we can then move on to the next phase now by coming here by closing this place now by coming to 3D model or plan view here. Now on the plan view now, we will then focus on the beam design. So we are now moving to the beam design because we are already done for our slab design. Now to do our slab, to now show our slab board like our slab rebars, I'll come here and make sure I set my spacing for my slab to be 200. I don't like using 250, which is the maximum. So I'll come here and set my slab spacing for my rebar to be 200 inside here, and come here and reduce this to what 200 millimeter, and I will click on what okay here. Okay, that's fine, and I'll click on what save. So you can see that this is checked and this is checked too. Okay, that is fine. So once I've done this two, now come here, right click here, and then do what, click on what update steel bar here. Okay, that is fine. So by doing that now, you will see that you can see your slab reinforcement has now appeared. Can you see that? You can see the diameter 16 at 200, but I don't want 16. I want 12 for my slab. So I will have to come back here and then change my reinforcement for my foundation slab to what, to be 12. Okay, I'll come back here and then change the material for the foundation to be what, to be 12 diameter and not 16 diameter. Come here and then change for my foundation. Where is that? This is it. I will change to 12. I will like add 12 into it. Okay, that is fine. And then click on what okay here, and I'll click on what okay, and then okay again, and then close, and then come back now, right click here and then say update again to update the new steel. Anywhere 12 is not sufficient, it will go and use what 16. Okay, but that's fine. So we need to do what, first of all, test run for 12. it is still showing 16. Okay, you can see that 16. Now let's go and check first if 12 can be okay by coming here again, back here, and then remove 16 and then just test run for only 12 to see if 12 is perfectly okay for that. Come back here and then come here and then come for foundation, uncheck 16 here, and then come for my slab here and uncheck 16, 20, 25 this, and leave only 12 for this. And now come and do what, say okay here and okay here. Come again here and then make sure I don't have this also checked here, and 16 checked here for my slab. This is slab. Okay, 12 checked. This is foundation. I want check 16 and check only 12 for now, since we are doing for the slab. After done for the slab, we're going to change for the beams. Okay, that's fine. So come again here and then say okay, 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 and close, and then save again here, and again come back here now, and then if it's not sufficient, you are going to see a warning will just come out on your screen that 12 is not sufficient. Okay, that is fine. Then come back here and then say update, and that will change, and then it will not do any design to test run the load and everything on the slab. So in this case, you can see that now have a 12 200. That's fine. So almost all of it's now is not 12, and you can see that some are 150. Can you see that? Some 150, some spacing. Okay, why some 200. Can you see that? Correct. So always verify to make sure that you can see here is 125. Okay, so verify to make sure that every places that you have is okay. That's fine. So like see different spacings. Okay, that's fine. We then move on to the beam design now. For I will then come and click on save here now. Now for the beam design now, we then move to we can change our rebar, and for the foundation and add 16 for the beams. So make sure you have beams, okay, added, which we already have, I believe so. Come back here, I then come back here, and then come and click here and make sure not here on the foundation floor, click here, and then come to this place here, and then even if it is checked for the beam to be 16, which you have here, make sure you check 16, 20, 25 for your foundation level. Okay, that is fine. Come here, check this, and then check this again. No, this one, that's fine. And then say okay, and then say okay, and then say okay, that's fine. Okay, and then close. Okay, that's fine. Then let's save once you're done with that. We then move to the next phase, which is now the beam design. We then come now and then go to this place here. For the beam design, come to your design tab here. Okay, that is fine. Design tab here, and click on foundation beams here. And then we then move to the this place. You can see that everything is failing before you can do, because we have not done anything yet for like the beam design. Before you can do anything, make sure you come to settings here first and set your concrete cover, else it's not design. Come to your beam design parameters here, and then choose foundation beams here. You can see that we have different beam, floor beam, beam, foundation beams. Come here and set cover 50, 50, 50. Okay, that is fine, 50. Then come here and set your minimum. You can see that it is showing 12, so we need to go and set that here must show 16 minimum and then maximum 25. Okay, that's fine. So come back here and then say okay, and then close here. Come back to our settings here, analysis here, and make sure that we are setting that. Come back here, then sorry, not here. Come here, edit material, and again let's check here for the foundation. Check here, then make sure you're choosing. You can see that it is only 12. On check 12, I don't like using 12, 16 minimum, and then 20, and then 25 if it fails more. Then click here and then say okay, and then say okay. Come again here and confirm that you have those bars selected. Come again here, confirm foundation, no 12. Click on okay, okay that, and close, and then save. Then come back to the settings again. Now you see that other bars is then going to appear. Not here first. Go to design tab here and then click on foundation design for the foundation beam. Then go to settings from here and then click on parameters for beam under beams. Then click on F foundation here. You can see that we have 16 minimum, 25 maximum. Then this is okay, this is okay. Then everything's okay. Make sure you have this set. Okay, that is fine. And then let's see here, everything here, nothing to do here. Yeah, it's okay. Then come here and do what, say okay here. Then once you've done that, now we're not going to do what, perform our beam foundation analysis by coming here that says what, batch mode. Click here. Now this is where we'll know if, then come here and do what, say with sled bar. Okay, that's fine. If any failure, it should use 20 or 25. Okay, that's fine. Instead of 16. Then this is where we'll know if the depth that we chose 800 is sufficient or not. If it's not sufficient, we can do what? Increase our depth of our beam, or the width to 250, or the depth to 850. Okay, that's fine. So this is now when we are going to know if this is okay or not. Okay, that's fine. We then hold on for a while for it to finish up. Then come and do what? Click on what? Okay here. Now you can see that everything has passed, but that it has passed doesn't mean that you would have to depend on the software. You need to do what? Do your check-ins. Okay, that is fine. So once you've done that, now if I now come and do what? Now click on close here, and then come to my 3D model here. Sorry, not here actually, but here. But I like that place to like load first. So I'll have to click on the 3D model here. Now on this, now once I click on this place now, and then I like to load, now I'll come back here to my view tab here, click on design status here. I can see that everything is showing green on the foundation, but even if it's showing green, this one we will design this toe slab separate because they are on a different level by adding our strip. Okay, strip. So you can see that everything is showing green for the beams, but even if it's showing green, you must check the beams, okay, to see what the software used to like design the beam by doing what? Coming here, right, and clicking on the beam, and then you have to do that from this interface here, from design tab here, and then click on this one here, and then you double click on this. Okay, that is fine, and you will see it will open the beam to show you the reinforcement that was used. Now in this place, that it is used what? Then 2 bottom and 2 top, which is okay, and this extra area of steel, okay, no one is showing green here, everything is okay. Now this one, ignore these ones. I've already explained this a lot on my videos before this time, so ignore this one once you're seeing this so that's not an issue. Then come and do a click on okay here, and then click on this one now, and then again check for the beams. You can see what the beam is giving you. I don't like having this bars here extra like a support bar here. I have to remove it, and then do what? Come and do what? And lap my bottom bar, lap it, and then lap here, also lap here to have just one bar instead of having bottom bars. Then instead of having support layers, lap here and then lap here, and again come here and remove this one here. Okay, that is fine. And again make sure that these things are lapped into the columns, else it's not nice. So lap this one also. Come here again, click here, and then click here, and then lap this, and then lap this one. Okay, that's fine. Here is failing. Even at 2, I will increase to 3. It has passed. Okay, that's fine. Here is okay. Once the value is more than 20, it's okay. Then you come here and then click on this here, and then click on here, and then come here, lap this into the column again, lap. Is okay, that's okay. So this is fine. Can you see that? So we have checked for this water beam now, and then we can now go and do what? Say now this is showing 1 point something. I have to do what? Increase here because it's very low. Okay, that's fine. It has not increased. Okay, that's fine. So it has now, you can see that. We'll then come and do what? Say okay. So you do the same thing for checking all the beams here. Okay, once you've checked all the beams now, you can then go and what? And generate your what? Like your report, either summary or detailed report, and then save as PDF. Okay, that's fine. This takes time to like generate, so I won't do this, but just click on this place now. Once you do that, then make sure you check all this now like this, and then click on what? Okay, it will generate the report. It can take like 20 minutes. Okay, but once it generates, you are going to see a PDF here at the top here. Say click PDF, and then it will say for you. That's fine. Then come and do a click on here, and then say cancel, and then you can come now and then click on here. Now once you've done to check all your beams, now we have checked for all the beams perfectly. So now we then come and do what? Design for our toe slab. To do for our toe slab design, make sure you click on the same thing, FE strip. Then on this place, now knowing that we use cantilever to like model for our toe, you come here and set for what? Cantilever, and then end that beam. And I want to draw from left to right. So my first point of strip is cantilever, face I'm facing, and then the last end I'm going to stop is at beam. So I'll click on cantilever and then beam, then come now and click on this point here, hold my shift key to keep the line, and then click on here, and then you find our this thing will just appear there. Now can you see that it has designed that? Now we are going to change this later to like 12 again because we are done with our beam design. Okay, and the check-ins. Then come again here and do the same thing again. Click on this one here, hold your shift key control key to keep the line straight, then click here. That's fine, and it will just design. Can you see that? Correct. So the same procedure for all the toe slab. Okay, that is fine. Now for this toe slab here, I am to cut from left to right again, still on X direction. I'll click on this because I'm to start with beam and then end in cantilever. Okay, that's fine. I then come and hold my control key to keep the line straight. Click first and then hold control key and then cut across the toe slab and then click clear. It will design the slab for you automatically, which will change to 12 later. Why 12 later, not 16. Then come again here now and then do for this other one too. The same condition. Click here and then come here and then click here. that's fine, and it will design for the slab for you there. Okay, that is fine. So the same thing for all other two slab. Okay, that is fine. Then for this other one now, we are cutting for all this other one. For this other one now, we are going to use this, start with beam and end the cantilever, and make sure you are on the y direction. Then I'll cut from down to up, not from up to down. From down now, which is starting with beam and then ending on cantilever. So I'll hold my control key and then click here, and that place with the design. So the same procedure again, and then come here again, do the same thing. For this other one, the same procedure, click here and then click here. That will give you that design, and again click here and then click up here, give it that one too. That is fine. Then we are done with that. Same thing here. Now this is that one. Now we are going to start with we are going to change the tweaking to a different thing, because now this is starting with cantilever and ending with beam. Okay, that's fine. So for this one, we are going to change the option and say start with cantilever and then end with beam. So we start by cutting from here, and then hold the control key and then click here, and then this will cut. You have that one. So the same procedure for these other ones too here. Come here to the same thing. Start with for this that small one here, and then end with beam. That will give you that one too there. Correct, that's fine. And again for here, start with cantilever and end on beam. That is fine. And again here too, start with cantilever and end on beam. That is fine. So with this, you can see that we have actually designed for all. Even this one now have a small one here, so we can also do for that, or just keep that one. So you can see that we have designed for all other those slab, which you can see here. So if we can check our 3D model now, which we have here, you can see that all our slabs now has now perfectly been designed for. Every foundation now is showing green, except we have to do something here to like design for this slab beam. So all the two slabs, you can see that they are all showing green. Even yes, they are all showing green. So let's see why that one is showing gray, because gray white means not in design. So this one, check this out now, which is directly at where. Let me see where this one is at this face. Let's verify that. You guys show me where that particular one is. That one would be, let me see, it's not here. It should be here. I think, I don't know. For you to get that, if you don't know, come here, zoom here, check the slab name. This is FS39. So we go back to our plan view here and drop down the slab list here and find FS39, which will be found. Let's see where that slab is. Where is that slab? This is the slab, very tiny. Can you see that here? So we are going to detail for this slab here so that it can be able to do a design. So this is the slab. You can see that FS39. Then come now, I will change to start with beam and end the cantilever, and I'll click here and then go like this and go like this. Control key and then click there. That will design that slab. So if we now go back to our 3D model here, you can see that that particular slab now has been designed for. Okay, you can see that. Yes, that's designed for. So you can ask, this is how to design for your foundation. Can you see that? We have designed specially for the raft foundation perfectly. Can you see that? So you can see how modeled, check, and everything. So this is how to design for raft foundation. You can just generate your report for your slab by coming here under foundation like this. Now right click here, and then you can generate your deflation check here by coming here, check this, and then say okay. That will give you your report. I will not do that now, it will take time. Again, for the slab report, come here, come to this other one here, click here, and again you check, you come here and say design report. It will give you a design report for that, but I won't do that now. Let's go and change this to 16 diameter, sorry, 12 diameter automatically. Then come back here now for our foundation slab under settings here, under here, settings here, then come here, analysis here, then come here, and then come to this place here, and then sorry, here, and again here, and then we come here, foundation, come here, and then we come to here and change this to take off all these and use only 12, not 12, just 12 alone, and then say okay, and come again here for foundation, take off all that and do only 12. Come here, this you only add 20 for like beams. If you're doing for slab, you only change it to 12. Okay, that is fine, because 12 is always good for slab, except in bigger structures. Then come here, right click here, and then always save first. Then once you're done saving, then come here, right click now, I click here and then say update step by to change everything now to 12, which to do a new design and check if it's sufficient or not sufficient. Okay, that is fine. So once it's done, it will display there for you. So this is it. Can see that 12, correct? So we are successfully designed for our slab, as you can see that for our raft foundation, which you can see here. I can just turn off these grid lines to have a clearer view here by coming here, turn this off, and then this off also here, and these two off also goes as off, and you cannot see our raft foundation perfectly designed for. Correct, that is fine. So you can see how we designed for this foundation right from the modeling phase up to this very phase, okay, up to the design phase. This is the full foundation design. Thank you very much and God bless you. Now, if this video finds you well, please give it a thumbs up and share with your friends and colleagues so that they can know what they're doing on design. That is fine. And then if you have any comments so far, drop it down on the comment section. If you want to enroll for academic training, go down to our Ekidel store right below this video description. You will get the link, or go to Google and type for Ekidel training. Okay, you can get the link to there. That is fine. Thank you and God bless you. Note that that discount 49.9% ends this month of July. Okay, that is fine. Thank you and God bless you. See you on my next video. Bye for now. Yeah, bye.